Alright, so remember we were talking about MVT, which stands for our mean value theorem. So this says for the following function, find the value guaranteed by MVT from -1 to 2. So remind me, what is our first step when doing a word problem or a true response question? Okay. Remember we had this on our little handout. I gave you with a little cactus on it. What does the first C stand for? Conditions. Conditions! Ah, okay. Do we have specific conditions that have to be met for our MVT? Yeah. What is our conditions?
Continuous and differentiable.
Alrighty. Is f of x both continuous and differentiable?
Yes.
Okay, what's our next thing we want to look at?
About.
Okay, what do we think this is going to be about? What is the specific test we're using? MVT, right? Which, for our MVT, what are the two things that your MVT is about? We have two things, one on the left, one on the right. We labeled them. Yeah, so those are the two things that we are about. The instantaneous rate of change and the average rate of change. Which one do we probably want to find first? Average rate of change. Because remember, our average rate of change is for the function that we were given. So we'll look at that first. So what's our interval? -1 to 2. So what would our average rate of change from -1 to 2 be? What's the formula?
F of 2 minus F of 1 over 2 minus
2 minus -1 though, right?
plus 1.
Yeah, so it'll become a plus 1. So what is f of 2? 8. What is f of 1?
1.
And then 2 minus a -1 gives us,
3.
oh no, sorry, it's not 1.
F of -1.
F of -1 is -1, there we go. I wrote f of 1. Drop the negative. Make sure that's a -1, because that's what our interval is. So yes, we get 3 on bottom, but then what do we get on top? 9, so 9 divided by 3 gives us, yes? What's our other about? What's the other thing that we need? Instantaneous rate of change. So that's going to be our derivative. What is our derivative? Okay. And we want our derivative to equal what?
3.
Okay. And what would we do to solve that? And we get. So what does x equal?
And negative.
Positive and negative what? So, what's our answer going? What's our next letter?
Context.
Context. So our context is in terms of C values in this case, right? Because that's what we were trying to find, is the C value guaranteed. What's our next variable? Or letter?
Time.
Time. specifically, so time is like your restriction. What was our restriction in this case? -1 and 2. So do both of those meet that requirement? -1 and +1?
Yeah.
So remember that our C value has to be between A and B. Yes? So are both -1 and 1 between A and B? No. Which one is between A and B? Positive 1. And then what's our last letter?
Unit or state. State the theorem.
Yeah. So we need to state it. So we would say by MVT. We don't necessarily have a unit because it's just an x value in this case, but it's a good thing to recall. We would say our context, remember, was C equals 1. Gives us f prime of x equals what? Three, right? That was the value we set it equal to, which is what was guaranteed to us by our average rate of change had to equal our instantaneous rate of change. Our C value is 1 is what guarantees that. What questions do we have there? So we've looked at a word problem. We've looked at one that is just a straight up equation. Lastly, we're going to look at a table. So the functions, that's spelled wrong, sorry. F and G are differentiable for all real numbers. The table shows values of f and g at various values of f. Let h of x equal f of g of x minus 3. Explain why there must be value c such that between 1 and 3, c is between 1 and 3, then h prime of c has to equal -2. So, again, starting at the top. What is our first C stand for? Conditions. Okay? Well, in this case, we kind of need to decide our second C, which is context as well. We need to decide what context we are using here. So what theorem are we going to use to prove that h prime of c equals -2? MVT. Why are we using MVT? Besides that we're just in the MVT section. What's the other theorem that guarantees values equal certain things? IVT. So how do I tell the difference if I'm using MVT or if I'm using IVT?
This one has a derivative.
Cool. So, notice that this is h prime, yes? And the information that they give us are our original functions, yes? Because it's not always necessarily, just because they give us the derivative, right? They could let us use the derivative as kind of our original function and give us information about the derivatives, and then we would be using IPT. Because we would just be saying values have to be between specific stuff if they gave us a table of derivative values. However, in this case, yes, they give us a table of original function values. They're asking us something about our derivative values, so we are going to be using MVT. Which means that our first thing is conditions. What conditions have to be met for MVT? Alright, are they that? Well, it tells us that they are what? So if f and g are differentiable, will h also be differentiable? Yes? If I composite two things that are differentiable, will that also be differentiable? Yeah. So, h of x is differentiable. What's the other requirement? Does it give us any information about that?
It was differentiable. It has to be continuous.
So remember that differentiability implies continuity. So h of x must also be continuous. Yes? So again, what's our about? What are we trying to answer our question? The C value, well, we're specifically explaining why there must be a C value. Yes? So why is there a guaranteed C value? We already answered our next one, which was our context, which we said specifically here we're using MVT. Okay, but in order to be able to use MVT, what do we need to find? What are the other about things? What were the two things that we said are in MVT? Average rate of change. Well, they already gave us the instantaneous rate of change part, right? We want h prime of c to equal -2. Okay, so what does that mean we must find, though? For what function? H of x, right? Because I'm trying to prove something about the h prime of x. That means that I have to find my average value also for h of x. So we have h of 3 minus h of 1 divided by 3 minus 1. Yes? Do they give us data on h? They don't give us on our table, right? But do they give us what h is? Yes. So h of 3 is going to equal f of g of 3 minus 3. And then h of 1 is going to be f of g of 1 minus 3. Yes? All over 2. Yes? Okay. What's going to happen with our 3? -3 minus the -3 is? It's not a trick question. -3 minus 3 is? Not quite. 0, right? Because I'm subtracting a negative, so it becomes positive. So I have -3 plus 3 is 0. Are we all okay with that?
Wait, it was -3 minus -3?
Yes, because I'm subtracting this whole thing. So I have to apply that negative on the outside to that -3 as well. So it ends up becoming plus 3. So -3 plus 3 gives us 0. So I can do that. Yes? And we don't really have to worry about them. And then we can use our table. So what is g of 3? 3. So then I have f of 3 minus, what is g of 1? 2. So then I have f of 2. What is f of 3? What is f of 2? 1 minus 5 gives us, divided by 2 gives us -2, which is what we wanted, because remember we wanted to be able to say that h prime of c equals -2. So we needed our average rate of change to equal -2. So then what do we want to do find C, yes, that would be our next step. Take our derivative, set it equal. But did it say like find the C value that makes that true? No, it just said explain why there has to be one. Yes. Have we technically done all the steps necessary to explain why there has to be one? Yeah. So then what can we do? What's our next stuff? Yeah. So therefore, by what? By MVT, there must be a what? BAC. What's our time here? Yeah, so C between 1 and 3 such that H prime of C equals negative. So like, here are my conditions, my about, my context. Here was our statement of our theorem. Our time was between 1 and 3. Yes, we didn't really have a unit value here, just like we didn't last time. So we've covered everything. Yes? What questions do we have there? Yes, maybe so.